Can you hear me now? Yes. So you can hear me now, right? Good. So this is the first day of the class. Yeah, this is the first day of class. We are going to study topic by topic on all the subjects we're supposed to learn. And I begin with algebra, okay? Now, you're going to get a homework, which is about 30 problems each time. And what I want you to do is you don't look at the answer key, you complete all the problems, then check it. If the answer does not match, the answer key doesn't match with the answers, you redo the problem. If you still cannot do that, and ask your parents to submit the list of problems you had trouble to solve, or you need more explanation. Then I will probably not immediately talk about it in the next class, because each time I have folks, I will write down the number, okay? Write down the problems and maybe wait for 1 week. I talk about similar problems together. Okay, got it? Yeah. So this is how do we improve it. So I begin with a kind of easy topic. It's algebra, because most of students are very good in algebra. You know, in the school, you know, you basically study algebra, okay? But I still want to talk about some problems from algebra and how to solve the equations. Someone want to, Alex Chen, okay. So let me go to Alex Chen. Okay, sorry. Okay. All right, now, so let's begin with the following problem. This is just a simplification of an algebra expression. Okay, trying to simplify. Okay, trying to simplify 6x to the 2a plus b minus c divided by 3x a plus 2b plus 3c. Now, this is just a fraction, right? So the only formula we need is the formula we're going to use is if we have x to the alpha times x to the beta, okay, it's going to be x to the alpha plus beta. Another formula is alpha divided by x beta is going to be alpha minus beta. Now, if you want to change, sometimes you get a negative power, so you can put it in the denominator, so you get a positive power. Sometimes you ask it to write down the expression with a positive power, so some terms will go to the denominator, some terms will go to the numerator. All right, so using those formulas, okay, the above expression will be first 6 over the above you have a 2a plus b minus c minus the power from the denominator. Okay, then you simplify it. So you have a 2a minus a is a, b minus 2b is minus b, negative c minus 3c is minus 4c. All right, now if a, b, c are all positive, you can also express it in a slightly different form. Okay, and you can also express in this form. So sometimes if you ask it to express them with the positive terms, okay, but yeah, we keep the last. Yeah, that's enough. Yeah, this is a simple form. We don't know a minus b minus 4ac whether it's positive or negative. Okay, so this is about simplification. Now we begin with the equation. Now we're going to talk about equations. So suppose you have 3 equations, c plus d equals 3, d plus c equals 4, c plus e equals 8. Okay, we want to find out c, d, e. Okay, so we have not a, b, c, d, e. Okay, now what is the best way to solve this type of problem? C, D, E. Okay, well, if you have 3 equations, you can solve for CDE, okay? Then multiply them out. So question, sometimes you don't need to solve them, okay? Sometimes you have to solve them. Solve for each individual value. But what is the quickest way to solve this equation for CDE? Okay, now first of all, you think about, okay, can I get product of CDE directly without finding the individual value of CDE? I look at that, it's hard, okay, I don't know. I have no clue right now, okay? So in this case, maybe you have to find a CDE, but what is the best way to find the CDE, okay? How to solve them? Okay, definitely can solve them, right? So the easiest way to do is you find the intermediate value, okay? So you add them together. You add them together, okay? You add them together, so you get C on the left-hand side. You have a C, 2C, 2D, 2Es. So 2C, 2D, 2Es. And the right-hand side will be 3 plus 4 plus 8. That's going to be 15. So now you get C plus D plus E is going to be 15 divided by 2, okay? If you use that, then you can find CDE quickly, okay? Otherwise, you see, how do you do that, right? You're trying to use a substitution. Yeah, we can talk about more general system linear equations. There's no, yeah, you have to step by step to find all the variables. But for this particular problem, there's still a short path there. So if you find the CDE, then you can find the C quickly, because C is going to be C plus D plus E minus D plus E. Okay, so 15 over 2. What is D and what is D and E? Okay, this is D and E. Okay, yeah. What is D and E? D and E is 4. D plus E is 4. So that is going to be 7 over 2. Okay, then how to find the D? D is a C plus D plus E minus A plus E, right? So we know already A plus E, C plus E, so C plus E. We know C plus E, that's a 3, okay? C plus E, let's double check. C plus E is 8, yeah, C plus E is 8. So it's gonna be 15 over 2 minus 8, and that is gonna be, yeah, it's negative 1/2, okay? Then finally, this is a C plus D minus C plus D, and then 15 over 2, C plus D is 3, okay? So after you combine them, 15 minus 6 is 9. Yeah, okay. Then the answer with CDE is going to be the product of those numbers. Okay, multiply them out, and it's going to be negative. Denominator is 8, the numerator is 63. Okay, 7 times 9 is 63. This is how do we get this formula. Okay. Yeah. Right. Right. Now, in general, okay, if you are given an equation like x plus y equals 5 and x plus y minus z equals 2, like, for example, x plus 2z equals 3, and how do you solve this type of system, we call it system of linear equations? Yeah, then I don't see any trick here, okay? Because if we add all together, I get 3x, 2y plus z. Does not help me to get simple equations, okay? So to solve this type of linear equations, you need we call it substitution, okay? The idea is, well, you can also use elimination, okay? The idea is to get the 2 equations in 2 variables. How can you do that? Well, I can say equation 2 minus equation 1. I get rid of x. So y minus y, right? So it's just z. And the 2 minus 5 negative 3. Then equation 3 minus equation 1. Then you get 2z minus y, right? And the 3 minus 5 is negative 2. So you get 2 equations in 2 variables. X is gone. Then you can quickly solve it. In this particular case, z equals 3 immediately. Then from here, since you already got 3 for z, so you get 2 times 3 minus y equals negative 2. Y is going to be 6 plus 2. It's 8. Okay. So once you get z and the y, then you can get x using any of the above equation. Okay, that's called the elimination method and plus substitution method. So by the first equation, x is going to be 5 minus y, and the width is y is going to be 8. That's negative 3. Right? So that's how do we solve these system linear equations in general. So you try to get rid of one variable and then get 2 equations in 2 variables, then you solve the system of 2 equations, 2 linear equations. Okay. Now, if you do not, let's go back to the original equation. If you do not add all those 3 equations together to get AC plus D plus E, what is the usual way you can do? Okay, the standard method. The standard method is you can solve for C in terms of D from the first equation and from, okay, then plug it into second equation, third equation, you get equation in D and E. Then you solve for D and E, then you get C. This is it's similar to this one, right? That's a standard method. All right. Okay. So let's take a look at the next problem. The next problem, so we are given the following information. Okay, we are given the following information. Here's the question. We have a integral triples of A, B, and C. Okay, have the property that each number is a product as a 2. Question is how many ordered integral triples you can find out. Okay, so let me write down the question. How many ordered integral triples A and the B and the C have the property that each number, okay, is a product as a 2. Okay. Yeah. So please don't join the screen. I can find out who did it. Okay, you can do that. Right. So you have A and B and C. Okay. So we have the properties here. A equals B times C. B equals A times C. C equals A times B. And here A and B, C are integers. Okay. Now, so we have a system of 3 equations. Okay. They're not linear equations this time. It's not like A equals B plus C, B equals A plus C. It's a product. Okay. Well, let's try to solve it. Okay. Those numbers must be integers, but this is here. I don't think we need even to assume that at the very beginning. Okay, you end up with those solutions. integer solutions. Okay. So the first case is if one of them is 0, because it's possible like 0, 0 is a solution, right? 0, 0 is a solution. Okay. When A 0, B 0, C 0, yes, 0 equals 0 times 0. This is a special solution. So now if, okay, if A 0, okay, you will see that if A 0, that implies B or C, that implies B 0, C 0, okay? Why? Because you can use the second equation, third equation, B equals 0, C equals 0. So then you get the above solution, 0, 0, 0. Okay. So we have to assume that we have to assume that A and B and C are all not equal to 0. Okay. But same is true. If B 0, then A, B, C are all 0. If C 0, then A, B, C are always 0. Okay. So we can assume that there are two cases here. Case 1, one of them is 0, then all of them be 0. Case 2 is no of them is 0. All right, and it's a similar idea. What you can do is you will get, let's try. There are many ways to do, right? You suppose you multiply them out, all of them. Okay, so left hand side, equation 1, equation 2, equation 3. Okay. So those are the just like add all those equations together. Here's the way I'm talking about product of two terms. So equation 1 times equation 2 times equation 3. What do you get? You get A and B and C. The right hand side is B, C, A, C, A, B. So it turns out to be A, B, C squared. Okay. Now, since A, B, C is not going to be the product of three numbers, is not going to be 0. So this implies A, B, C is going to be 1. Do you agree? Okay. So the product of those numbers is going to be 1. The reason is, think about this is x, right? It's going to be like x equals x squared. Now x is not going to be 0 because A, B, C are not none of them 0. So the product is not 0. So if x is not 0, then divide both sides by x, so you get 1. So that's the reason. Okay. So A, B, C is 0. Okay. Then what do you get? Well, from the above equation, right? A, B, C is equal to 0. So how do you get A? How do you get B? Well, the above equation tells you that A equals B times C, right? So A squared is going to be A times, because A is a BC, so A is a B times, right? A is B times C. So that's going to be 1, right? Similarly, right? So this is because A equals B times C. Now, similarly, B squared equals B times AC, right? And that is going to be 1. And C squared equals C times AB, right? Because C is going to be A times B. That's also equal 1. So now A squared, B squared, C squared all equal to 1. So the possible solutions, A is going to be plus minus 1, B is plus minus 1, C is plus minus 1. And but looks like you're going to have a 2 times 2 times 2 is 8 possible solutions. But you can check that not all of them meet the requirement, those equations. So I think that you can quickly list all of the the solutions. Okay. So when A equals 1, then B equals 1, C equals 1, or B equals -1, C equals -1. So you're going to get 1, 1, 1, 1, negative 1, negative 1. Okay, another choice is when A is negative 1. Okay, when A is negative 1. And I think you can also get those two solutions. So basically you need 2 negative ones, 1 positive ones, or 3 positive ones. So total you have how many solutions you can get? 1, 2, 3. As long as you know A, B, C are all plus minus 1, then you can check that 4 of this 8, okay, possible solutions will be other solutions indeed. Okay. So go over this problem again. The key point here is you multiply the 3 questions together. Okay, just like 8 3 questions. You multiply them together, you get A times B times C equals 1. Okay. Then using the original 3 questions again, you can quickly get A squared, not A, but A squared. But A squared equals 1 because then you almost determine the value of A, B, and C. Okay. And just make sure they meet the requirement. Okay. Make sure they meet the requirement. All right. So yeah, you know, right? How to solve equation. There is a still kind of shortcut in the middle. Okay. Either multiply all the 3 equations together or add those 3 equations together. All right. Now, have you heard about the golden mean? The golden mean, G, is a positive number. Okay. Is a positive number. Okay. That is 1 more than its reciprocal. That is 1 more than its reciprocal. So how do you, find this G? I'm curious about this golden mean. Okay, this is a special number. Maybe there's no such number, right? So to find the G, and how to do that, you write down, translate the sentence into an equation. Okay, so 1 more than the reciprocal. So that is the equation. But this is a very strange equation. It's not a linear equation, right? How do you solve it? It's not a linear equation. Okay. Well, you modify it. Okay, how do you modify it? You don't like the fraction, so you multiply by both sides by G. So the G squared equals 1 over G times G is 1, and that is quadratic equation. At this point, we still don't know whether you have a solution or not. Okay, then given a quadratic equation, how do you solve it? Well, how to solve it? Sometimes we can factor this quadratic equation, and sometimes it's impossible to do that. It's very difficult. Okay, so we have the general formula. If you are given this quadratic equation, A is not equal to 0, then you have 2 solutions, possible 2 solutions, negative B plus minus B squared minus 4AC. And if B squared minus 4AC is positive, you get 2 real numbers. And if B squared minus 4AC is 0, you get only 1 real number. If B squared minus 4AC is negative, you have no real number solution. Okay. So yeah. Okay. So look at this is a formula we should know. Okay. So now let's go back to the equation. A is gonna be 1, B is negative 1, C is negative 1. So G should be equal to 2 times 1, negative B is positive, plus minus B squared Okay, b squared, that's going to be negative 1 squared minus 4ac. All right, any questions? All right, so simplifying this, you will get 1 plus minus 1 plus 4, it's 5. Now you have two solutions here for that equation, but our golden mean is a positive number. So clearly 1 is less than square root 5. So the solution will be 1 plus square root 5 over 2. Now, how large is this number? Can you do some estimate of this number? Okay. Yeah, how do you estimate? It without using calculator. Okay. But this number, rough estimate, is going to be, okay, let's get a lower bound. Okay. Lower bound is greater than or equal to square root of 5 is greater than 4, right? So that's 3 over 2. So it's greater than 1 point. Yeah, 1 plus 2 is 3, numerator. So it's 1.5, greater than 1.5. Now, this number has an upper bound. What is a perfect square greater than 5? Square root of 9, right? So it's going to be 1 plus 3 over 2, which is 2. Okay, so this golden number is less than 2, greater than 3 over 2. Okay, so you can get a rough estimate. Actually, if you use a calculator, you will get, you will get about 1.62. Okay. Yeah, sometimes you don't have a calculator. So how do you estimate a number involving radicals? You just you just give upper bound, lower bound for that integer inside the radical. Okay, so that those upper bound are perfect squares. The lower bound is also perfect squares. Okay, then you can get estimate quickly. Okay. All right, so let's take a look at the next one. This is from Mathcounts. Okay, solve the equation 222 to the power x equals 7. Oops. Equals 7 times 111 to the power x plus 111. Yeah. Oh, the original equation will be actually when 111 is to the power x is on the left hand side. Okay, minus 111 to the x equals 111 to the x times 7. Okay, we're trying to find x. You have to simplify this equation. Okay. Okay, otherwise it's pretty large number, right? A very large number to some power. Okay, and before we solve the problem, let's talk about the exponential function. So you have a number a, so you can define this. Okay, so we know that, if you have this equation, okay, a is not going to be a 1, okay, then it implies that x should be equal to y, okay. So if we are able to simplify the above inequalities into a simple form, you can solve it. Okay. So how do you do that? Well, 222 is going to be 2 times 111, right? That's all we need. So it's going to be 2 to the x times 111 minus, okay. Okay. So yeah, you change this problem a little bit, right? Modify this equation. Okay, who is speaking? Please mute yourself. Okay. Okay. So you get this equation. Now, can you simplify it? There's a common factor here. The common factor is 2 to the x. You can move 111x to the right hand side. Okay, so we'll get 8 times 111 to the x. Then this is a common factor. You can get rid of that. Okay. 111, so you don't need it. Actually, you end up with a very simple equation. Okay. Now, when you get an equation like that, can you get x? Well, you needed to know 8 is 2 cubed. Then 2 to the x equals 2 cubed. So x should be equal to 3. Okay. So you get the final answer. Okay. All right. I'm going to test you about another problem. Okay. You are given solve this equation. We know that there exists a non-negative integer a and b such that for any x satisfying a less than b less than x, it is true that, well, it's making it complicated. I just want you to solve this equation. Okay, x is some real number. Okay, now how do you solve this equation? I saw this problem on some Mathcounts competition. Okay. Right. Now be careful about this. Okay. When you look at this inequality, okay, x is inside the square root, right? So when you be careful, you cannot just square both sides directly, otherwise you'll make mistakes. Okay. Yeah, there are some steps is you do be careful when you go move on to the next step, because when you square up, okay, what I want to say that those two are not equivalent. If a greater than b, okay, does not imply a square greater than b square. Okay, it's not true. Okay, it's not true. Okay, so why? Here's the example, right? 1 is greater than -2, right? But this does not imply 1 square greater than -2 square, because -2 square is 4. So be careful when you square both sides. Okay. Yeah. So in general, it's not going a greater than b is not going to does not imply a square greater than b square if they have an opposite, different signs. So you cannot just square both sides to solve this inequality. First of all, you make observation. Can x be negative? No, x cannot be negative. X must be greater than or equal to 0. Okay. X must be greater than or equal to 0. Okay. Right? So that is, you have to make sure Right. So that's the first observation you have to make. So then there are two possibilities. If x is 0, what happens? If x is 0, you have 0 greater than 0. It's impossible, right? Okay. So in that case, it's true. So now you conclude that x is greater than 0, right? If x is greater than 0, then you can actually they can square both sides. Okay, so I need yeah. Then you can square it actually when it's positive. Okay. Then you can square both sides. Okay. Then you get x greater than x squared. Okay. Now that's not good enough yet, right? So you can move, doesn't matter, move x squared to the left. Okay. Then you take x out, right? So x times 1 minus x greater than 0. But we know that this is a positive, right? So 1 minus x should be greater. So that's why that is why x is going to be, that is why x should be greater than 1. Okay. So when x is positive, x must be less than 1. So your answer is here is x is greater than 0 and less than 1. Okay. X cannot be 0. Okay. This is the answer. All right. Yeah. Now, yeah, let me state the following fact. If A and B are positive, okay, then A greater than B is if and only if A squared is greater than B squared. Okay, so those two are equivalent. Okay. Yeah. So this is a pretty tricky inequality. Now, the next problem. Let's look at the system of two linear equations. Okay. Okay. We want to find the k for which these two equations will not have a common solution. Now you can solve this problem using geometry method, or you can just go ahead directly trying to solve it. Okay. Look at these two equations, right? So how do you solve it? Use a yeah. So there are a couple ways to do. Okay. You can also get solution from the geometry. You know, this is it's because each equation here represents a line in the xy plane. But we're talking about coordinate geometry later. So let's just try to solve these two equations. Okay. By the first equation, okay, you assume, you know, yeah, k some value. I'm trying to solve it, right? And then later on, you determine for which value k, there's no solution. Will not have a common solution means this system of linear equations do not have a solution. Okay. So by the first equation, when you do the homework, you needed to say a few words every time, so people can understand what we're talking about. Okay. So I'm going to get, you can solve for y in terms of x. So 4y equals -6 plus 7 Then I divide both sides by 4, 3 over 2, and here 7 over 4. Okay, so this equation, okay, just just a modified version of the first. Then I plug it into go to the second equation. So kx plus 8, y is going to be given by this. Okay, then I hope I can find x from this equation. So you get 4, I think this is going to be 12x plus 14, 8 times 7 over 4. Okay, so finally you will get k minus 12x equals negative 7. Now, can you solve for x? Well, yes. When? When k is not equal to, when k is not going to be 12. So if k minus 12 is not going to be 0, you get solution for x. Once you get solution for x, you can get solution for y. So that means there's a solution. But the question is, for what value k, there's no solution. So the answer should be k equals 12, because when k equals 12, you cannot solve it, because you end up with 0 times x equals negative 7. Impossible. No solution. Okay? If k equals 12, you end up with the equation 0 times x minus negative 7. So that's no solution. Okay? Yeah. So you just pretend that there is a solution, trying to solve it. At the end, you will see for what value k, there is no solution. All right. That's a standard method. Okay, that's a standard method. All right. Let's look at another system of linear equations. You have 8, 8, 8x, 8, 8, 9y equals 890. Okay, 891x plus 892y equals 893. Okay. I'm going to find x and y. Yeah, solve this question. Well, we know how to solve this system linear equations, right? Just like what I did last. Okay, solve for y in terms of x, then you plug into the second equation. But the trouble is they're bigger numbers. They're too big. We don't like it. Okay, it's not like here. You see, by the first equation, I can get the y equals negative 3 over 2, x plus 7 over 4. But here, it's a headache. You can solve for y in terms of x, and then plug y. Yeah, plug it for y into the second equation, you can get equation x. But those are too large numbers. It's harder to deal with. Okay, so that's equation 1, equation 2. I think we can get a simple equation from this 2. Equation 1 minus equation 2. Okay, 891 minus 888, that is 3x. 892 minus 889, it's a 3y. Then how about this? This is 3. So you end up with very simple equation, x plus y equals 1. That's equation 3. If you can get to that point, then you can quickly solve for x and y. Okay. Yeah, you should look for some simple equation. Not necessarily you can solve it immediately. Can be simple equations that let's say x and y. Okay. Then you can solve for y. Okay, then you plug into the second equation. Then you get 891x plus 892. Y is 1 minus x equals 893. Okay, then you will see that then you solve that, right? Okay, 891, 892 is negative x. Then you move this number to the right-hand side. It's going to be positive 1. So x is going to be negative 1. X is going to be 1, y is going to be 1. Y is 1 minus negative 1, that's 2. Okay. So yes, the coefficient is very large, but there's a way you can get a simple equation. Just subtract equation 2 from equation 1. You cannot eliminate a variable by subtraction, but you still get a very simple equation. And from here you can solve the system of linear equations. Okay. So we have another one. Okay. We know that the cube of a positive integer n is 9 less than 9 plus n plus 9 square. So what is n? Now what does that mean? Just write down this equation. N plus 9 square minus 9. Okay, because 9 less than n plus 9 square. The cube of a number n is going to be n plus 9 square minus 9. Okay, so question is, how can I find a solution? Because when you look at this equation, how can I find all the solutions? We don't have any formulas to solve not a quadratic equation, equation of polynomial degree 3. Okay. You can, if by guess and try, maybe you will not get all the solutions. Okay, so let's modify a little bit, because 9 is 3 squared. So I can express it in this form: n plus 9 plus 3 is 12. 9 minus 3 is going to be 6. So we are looking for an integer. Yes, integer set from this equation. Well, from here you can see that integers n is greater than 1, right? So you can get a lower bound for this, right? It's going to be 1 plus 12, 1 plus 1 plus 12, it's 13 times 7. Okay, So let's see what is that number. Okay, so that number is going to be 13 times 7. It's going to be 91. Okay, now can n be too small? If n is 4, right? 4 cubed. What is 4 cubed? 4 cubed is 64, right? So clearly n should be greater than, because n cubed right now is greater than or equal to 91. So n cubed must be greater than 5. Okay, all right. So n cannot be smaller than 4. So now you just double check. So this is a cube, right? This is still less than, okay, 5 plus, it's a 17 times 11. So they're not equal. Okay, and you were surprised this will be equal when n equals 6. It's 18 times 12. Okay, then after that, the cube is much larger than the, yeah, it's 19 times 13. Okay, so this is the only solution you can get when n is equal to 6. Okay, why there's no other solutions? Why this is enough? Because n cubed grows faster than square. Okay, so after you find out 7 cubed is greater than 19 times 13, then after that, you know, this is n cubed is always greater than n plus 12 and n plus 6. Okay. All right, my next question will be 1 over x plus 1 over y equals 3, and 1 over x minus 1 over y equals -7. And we're trying to find x plus y. Okay. All right. How do you solve this? Well, when you look at this 2 equation, I find out x only shows up in 1 over x, y only shows up in 1 over y. So the method we are going to use is called substitution. You can let a to be 1 over x, b to be 1 over y. Then you end up with a plus b equals 3, a minus b equals -7. So the equation looks much simpler, right? Then you just add the 2 equations together. You know, 1 equation 1 plus equation 2, they get 2a, and 3 plus -7 is negative, right? It's -4, so a is going to be -2. And similarly, equation 1 minus equation 2, you got 2b, 3 minus -7, that is going to be 10, so b equals 5. So once you get a and b, you can get x, because this is the 1 over x, that's the 1 over y, and that implies x is going to be 1 over -2. That implies y is going to be 1 over 5. Okay, so sometimes if you introduce a substitution, yeah, it will make the problem simpler. Okay. So you have to modify the equation to solve it. Okay, here's another equation. Looks like it's not a quadratic equation. It's not a linear equation. What is the list value of x for which the following equation holds? Okay, don't be confused with this equation. You cannot try, list the value, and I do not assume x is positive. Right? I do not assume x is positive. Okay. So if you have no clue, just trying to find all the possible solutions. Okay, then pick up the smallest one, right? That's the nature idea. Okay, so how do you do that? So you multiply this out. Then some students maybe think, oh, then I can quickly solve it. Why? Because this is consecutive numbers. Okay, this is like x plus 1, x plus 2. So there's a quicker solution. Now, this is misleading a little bit. So you can say, okay, x plus 2 should be equal to 4. So x plus 1 equals 1. So I get solutions. Okay, x is going to be 2. Okay, x plus 1 equals 3. Perfect. So you get one solution. So the answer is x equals 2. Okay. Don't forget, okay, if you want to do this way, fine. But you have to be very cautious. Why? Because x plus 1, x plus 2 is also going to be -3 times -4. In that case, which one is larger? -3, -4 is smaller, right? So it's going to be -4 and -3. So x plus 1 should be -4, x plus 2 should be -3. Now in this case, x is going to be -5. So -5 is going to be also a solution. You have to be very careful if you do it this way without solving the quadratic equation. Okay. So the answer will be this one. You see, it's very difficult. It's easy to miss that solution. If you're too smart, just recognize, oh, x plus 1 times x plus 2 is a product of two consecutive numbers, and on the right hand side 3 times 4. So therefore x plus 1 should be 3. Then you get wrong answer. Okay. Now some students probably did not see that. Okay, I'm just go ahead to multiply this out. X plus 1 times x plus 2 be 3x plus 3 plus 2 equals 12, right? Then you end up an equation. Okay, then you can fact it. Okay, right? Fact it. 5 times -2 is -10. 5 plus -2 is going to be 3. Okay, so you can use a quadratic formula to find it. Then you still get the solution you want, right? Yeah, you still get solutions you want. So yeah, yeah. Let me talk about the last problem. Okay, if x plus y plus z to the 4th power is multiply out. Right? And the like term will be collected together. combine. What is the coefficient of x squared y z term? Aha. Okay, what is the best way to do? When you multiply this out, yeah, you do have terms like that. X squared plus y, there are other terms too. Okay, if you multiply this out, you definitely have x to the fourth power. Then you have x, x cubed, then y, then you have x. Also, there are some coefficients here. Sometimes contains only two factors. That's too complicated, right? And x cubed z, and it's so many terms. First of all, you have to waste lots of time to multiply this out. Okay. My idea is I want to first of all, I have x plus a squared to the fourth power. So how do we get x squared? It's x squared plus 2ax plus a squared, right? Now how to get x plus a cubed? Then I have x cubed. 1 plus, it's a 3. Yeah. So let's use x here. X squared a plus 3x a squared and plus a cubed. How can I get x plus a to the fourth power? The x to the fourth power. And the coefficients determined by those two. 1 plus 3 is 4. And 3 plus 3 is 6. And 3 plus 1 is 4. Okay. And then a to the fourth power. Okay. So that's all I need. Once I get that, then I replace a by x plus y plus z. Okay, so then I get x to the fourth power, 4x cubed, and then y plus z, and here x squared, y plus z squared, then here 4x, y plus z cubed, and y plus z cubed, z to the fourth power. So you want to determine the coefficients x squared y z, and you can quickly see where it's from. Okay, and you don't need to multiply them out. Okay, so you definitely does not come from here, does not come from here, and it does not come from here, does not come from here. So you only need to look at this term. Okay, so that's how you get the answer. Okay, yeah, that's how you get the answer. So you will get, 6x squared. Here's a y squared plus 2yz plus z squared. And clearly, x squared yz is here. So it is going to be 12x squared yz. That's the only term, okay, with x squared yz. So the answer is 12, okay? So this will be the answer. Yeah, don't waste time to get all the terms which are useless, okay? It's nothing to do with the problem. You have to find out how to get x squared yz here, okay, quickly, okay? And you see that x plus yz to fourth power, x squared yz come from here. Then you don't need to look at the other terms. Okay. So those are the algebra. I call it algebra. Equation is part of algebra. Okay. Algebra contains equations. Algebra also contains word problems. You set up equations to solve story problems. we're going to work on the other type of algebra. Okay. Then we study number theory, with all kind of other topics. But algebra today we focus on equations. Okay. And then we're going to study number theory problem. We go over number theory problems. Okay. All right. So well, we stop here. Okay. So you